Hello everyone and welcome back. My name is Mr. Covalt, and in this video I'm going to be talking about the prediction of products of electrolysis and in particular aqueous solutions. So in my previous videos where I was talking about predicting the products of electrolysis, we were dealing with molten substances. But here we're dealing with aqueous solutions, and therefore we have to worry about water because water can be both oxidized or reduced, and so that's going to be a contender for those processes. So let's get into this. So here I have water being oxidized and reduced. So at the anode, oxidation is occurring, and so I have two water molecules uh, going to oxygen gas plus four hydrogen ions plus four electrons. And so that's going to have a standard electrode potential of 1.24 volts. But it's also, since water is not really under standard conditions, if you're talking about the amount of H plus in water, that's going to be 1 times 10 to the negative 7 molar for pure water. So that is not going to be standard. So the non-standard electrode potential for the oxidation of water at the anode is going to be 0.82 volts. At the cathode, we have reduction occurring, and that's where two water molecules pick up two electrons. That's going to form hydrogen gas plus two hydroxide ions, and that is going to have a standard electrode potential of negative 0.83. And again, since the hydrogen ion is not at standard, it's not 1 molar concentration, it's at, again, 1 times 10 to the negative 7 molar. That's not going to be standard. So that electrode potential is going to be a negative 0.41 volts. So those are the reduction and oxidation half reactions for water. And again, to find the the potential of a cell, we take the electrode potential of the cation and subtract that from the anion. So if we were to take these, then we would get a negative 0.41 volts minus 0.82 volts, and we get a negative 1.23 volts for that process. Okay, so let's look at an example. So here I have an aqueous solution of sodium and iodine. So here, sodium iodide, I have sodium ions and iodide ions in solution, but along with that, I have water. So we have to look at the oxidation and reduction of water at both electrodes in competition with that of the iodide ion and the sodium ion. So here I have listed the possibilities. These are the possible oxidations that can occur at the anode. So here I have the oxidation of the iodide ion, and I also have the oxidation of water. And here at the cathode, there's two possibilities of reduction. Again, I have the reduction of sodium at the anode, and I have the reduction of water at the anode. I mean, at the cathode, excuse me. So what we need to do is, once we set this up, we need to then figure out, well, what's going to happen at the anode, what's going to happen at the cathode. And therefore, we got to go back to looking at the electrode potentials. So here, for the anode, we want to know which one is going to be the more negative, right? The more negative one is going to push the electrons away. That one is going to be more easily oxidized at the anode. So we look at this, okay, which one of these is more negative? Or the other way to put it is, which one is less positive? So if we look at the less positive one, we see that this one here, the oxidation of iodide ion, is less positive or more negative, and therefore we would expect the oxidation of iodide ion to occur at the anode compared to water, because it's more negative or less positive than that of the water. So this is what we would predict to happen at the anode. What about at the cathode? So again, at the cathode, what we're looking at is the more positive electrode potential, because again, the positive is drawing the electrons to that electrode. So more positive means more easily reduced. And so we're looking at the more positive. Here we have a negative 2.71, and here we have a negative 0.41. So this is more negative, or another way to put it is less positive. So this one's less positive, this one's less negative or more positive here. So this would be the more positive reaction or electrode potential. So therefore, we would expect here the reduction of water to take place at the cathode, not the reduction of the sodium ion. So the reduction of water would happen at the cathode, and at the anode, you'd have the oxidation of the iodide ion. So that is how you predict what's going to happen at the each electrode when you have an aqueous solution. So which reaction really occurs? Well, it's the half reaction that occurs most easily. What is the reaction that occurs most easily? Well, at the anode, it's going to be the one that has a more negative or less positive electrode potential. And at the cathode, it's going to be the one that has a more positive or less negative electrode potential. So one last note, really important note, that would be a good general observation that we want to make is that the cations of active metals, what are those? Those would be those that are not easily reduced, such as lithium plus, the potassium ion, sodium ion, magnesium ion, calcium ion, and aluminum ion. These are not going to be reduced in aqueous solution because water is going to be the more easily reducible species in the solution. So that is a general thing to keep in mind when you're thinking about aqueous solutions and whether or not electrolysis is going to work, especially when you're trying to figure out what's going to occur at the anode and the cathode. So I hope this video was helpful. That's all I have for right now. So if you enjoyed this video, if you learned from this video, please by all means like and share this video. Hit that like button right there. Also, when you hit that, also subscribe to my channel. And if you hit that notification bell right up there, make sure that you hit all, click all so you could be notified by all my videos that I put out. And finally, put a comment down in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. Thanks for joining me and have a great day.